Hi guys, in this video we are going to be learning about transformations. So we're going to take our parent functions that we talked about yesterday and we are going to apply horizontal and vertical shifts to them. So we're going to see how adding numbers on the inside and the outside affect the graph. So that is going to be our objective for today. By the end of the lesson you should be able to say, I know how adding and subtracting numbers on the inside and outside of functions affects their graphs. So first of all, we need to kind of look at what is the inside or the outside of a function. Okay, so there's quite a few functions on this slide. We're going to talk about each one. We're just going to quickly say what the parent function is for the function, and then we're going to say if the transformations are occurring inside or outside of the function. So the inside of the function, that means that whatever is happening to x. And it's going to be usually on the inside of parentheses or absolute value bars or square roots. The outside of the function is happening to the whole function, so that's y. It's happening to y. And the outside of the function is generally going to be outside of the parentheses or the absolute value bars or the square root. A couple of the functions are a little different, but we'll talk about those as we go. So just because if we cannot determine which is the inside and which is the outside, we won't be able to basically have this discussion. So let's do this first. So this first function, my parent function here is exponential because it's raised to the power of x, right? The x is the exponent, which means this is exponential. This one is actually a parent function, 2 to the x. So this one has no transformation happening inside or outside. But if I were to add, for example, like a plus 2 up here in the exponent so that that plus 2 is with x, if something is with x, that means it's on the inside of the function. That change is happening inside. For an exponential function, if the change were on the outside, it would be a big plus 5 or minus 5, or minus or plus any number for that matter. So the difference here is that if it's on the inside, it's going to be up in the exponent with x. If it's on the outside, it's going to be down here, a big number with the base number. Okay? This one's outside, this one's inside. X plus 3 cubed, because of that third power, this is a cubic function, and because this plus 5 is happening on the inside of the parentheses here, it's happening before the third power is applied, this is on the inside. Here we have a quadratic function, and we have actually 3 different transformations. We have a multiplied by 2 on the outside, a minus 1 on the inside, and a plus 3 on the outside. So again, everything that happens on the outside of the parentheses is considered outside of the function. Everything that happens inside the parentheses is inside. This function is linear because x is to the first power. With linear functions, there is really no distinguishing inside from outside, and they both kind of do the same thing. So we'll talk more about linear functions later, but on a linear function, there really is no inside or outside. But the same type of transformations will happen. I accidentally got 2 rows up here at once. I guess we'll go back. So here we have a square root function. Everything is happening inside the square root, which means the changes on this function are inside. Here we have another exponential. We have a minus 1 on the inside and a plus 3 on the outside. Okay, remember anything that happens in here with x is inside. This minus 4 is inside of this cubic function. This 2 and this negative 1 are both on the outside. Again, we have a linear function, so there is really no inside or outside, but we'll talk about what these things do to linear functions as we go later on. This one is also exponential because x is in the exponent. And if I do a plus 2 like this, it's going to be on the outside because it's a big plus 2, right? It's not up here with x. Another linear function, this one is absolute value. This minus 3 is on the inside of the absolute value bar, so it's also on the inside of the function. And the plus 2 is on the outside. Here we have a quadratic function because it is squared. We have 2 things on the outside and 1 thing on the inside. Here we have a cubic function. This 3 is on the outside because, again, if it's on the cubic function, anything that's inside the parentheses is going to be on the inside, but anything that's not is outside. So even if it doesn't have parentheses, that means there's nothing happening on the inside with x, and so that 3 would be outside. Here on this absolute value function, we have a times 2 on the outside and a plus 1 on the inside. Here on this square root function, we have an outside negative, and we have an inside times 4 and an inside plus 7, so inside, inside, and outside. Another linear function, so we can't really distinguish between inside and outside. Here we have another square root function. This 1/4 is on the outside, this minus 5 is on the outside. There's nothing happening on the inside with x. Another exponential function. Remember that if it's up here, little plus 3, that's on the inside. On this absolute value function, I've got a minus 7 on the inside and a minus 6 on the outside. And on this cubic function, I've got a plus 2 on the outside. Remember, cubic and square root, you'll always have, or not square root, cubic and squared or quadratic, you'll always have the inside being inside of parentheses. Okay? So that's just a quick rundown of how to tell if the function is changing inside or outside. Now we're going to talk about how to graph, or how to see what happens on the graph when we have these. Today we're specifically dealing with when we add or subtract a number on the inside or outside. So we're not going to deal with multiplying until tomorrow. But this plus 2 is on the inside. So what happens if you put a plus 2 on the inside or on the outside is that it's going to be a shift. Now a shift is, another name for that is slide, or sometimes another word for that is a translation. 3 names for the same thing. It basically just means you take your graph wherever it is and you slide it right or left or up or down. Okay? So if the adding or subtracting, so here we have x plus or minus c, so that means the plus or minus of a constant is happening on the inside of the function. So we have an inside plus or minus, okay? Some number c, that means it's going to go right or left. So if it's on the inside, say here's x on the inside of this function, then if that plus or minus happens on the inside with x, that's going to move things right or left, because that's where our x-axis is. Okay, so it's going to be a right or left shift if it's on the inside. Also, if it's on the inside, we say that inside lies, because if we have plus 2, we would think it would go right 2, but what that actually does is this goes left 2. So we say that inside lies because it does the opposite of what we would think it would do. So the reason it does that is because, think of this as y equals the absolute value of x plus 2. This function is in terms of y right now. So y is what is solved for. If we wanted to put it in terms of x, we would have to subtract 2 from both sides in order to get x by itself, right? So that shift would actually be left 2. So what we need to do in order to actually graph this is we need to think about the parent function. So the parent function for absolute value is the absolute value of x. And we know from yesterday that the absolute value of x, that parent function, sits right here at 0, 0, and goes up and makes a V shape. Okay, and wow, that's really not straight, but it's kind of hard on this to write straight. So it makes a V shape sitting right there at 0, 0. So if this one moves everything left 2, that basically just means we're going to take this same function, and my colors are hidden here. See if I can get it. And well, I guess not, but we're going to move it left 2. So it's going to be the same function, just over left 2. It won't be any different shape. It won't be any wider or narrower. It will be exactly the same, just every point moved left 2. Okay? So that's what happens when the plus or minus is on the outside. So if we add or subtract a constant number, it shifts right or left and inside lies. Okay? Now if it's on the outside, and we'll do some examples where they're on the outside in a few moments, and we add or subtract a constant, then it's going to shift up or down, and this one goes the direction you think it would do. So if I had like a plus 4 out here, that plus 4 would make it go up 4. So this would also go up 4. So it would be right there. Okay, so let's take a look at another example. So this one is a cubic function, and that's important because that helps me to know what the parent function looks like. This minus 5 is on the inside, which means it's going to move right or left. And again, inside lies, so that means this is going to go right 5. So first, let's graph the parent function. So we're graphing g of x equals x cubed. So if you remember from yesterday, that sits at 0, 0, and it goes up to the right and goes down to the left. So it looks somewhat like that. And then if we moved everything there right 5, 1, 2, 3, 4, 5, the center would now be here, and everything else would just be the same. Every point would just move right 5. So it would look like this. So this is x minus 5 to the third, and this is just x to the third. So in order to graph these, you always need to have in mind what the parent function looks like and where it is relative to the origin so that we can move things around. Okay, here we have x squared plus 5. So this is quadratic, which means I'm expecting it to have that U shape, that parabola shape. The plus 5 is on the outside, which means this should move up 5. It's just going to move every point up 5. So again, I need to graph the parent function, which is just x squared. And I know that one sits right here at 0, 0. And goes up something like this. Okay. And so because this has moved it up 5, I'll just count up 5, and it's going to, again, be the same shape, same width, everything, just every point moved up 5. Okay. So this notation here is saying that my function has a plus or minus constant outside, right? It's not inside with x, it's on the outside of the function, which moves it up or down on the y-axis. So here we have x minus 6. Now this one's linear. So I told you before, you can't really distinguish between outside and inside when you have linear. So if we're talking about linear and we were to call this on the inside, then we would say, well, it went right 6. But if we were saying the minus 6 is on the outside, so let's write that. So inside would move it right 6. If I said it's on the outside, it would be moving this down 6. So let's think about what actually would happen here. So the parent function for linear is y equals x, which means when x is 0, y is 0. When x is 1, y is 1. Basically, it's just this diagonal, right? When x and y are always equal to each other. So this would be my line. I'll see if I can connect it without going too off. There we go. So there's y equals x. So this is the parent function. Well, if I subtract 6, that means now I'm going to be crossing the x-axis at negative 6, right? Because remember that a linear function is y equals mx plus b. That b is the y-intercept, so it's where it crosses the y-axis. And then our slope is m. And that slope, in this case, would just be a 1, which means up 1 over 1, up 1 over 1, right? So it's going to be parallel to this line here. Okay, so there's our transformed line. It slid. But now notice that if our minus 6 on the inside, it went right 6, which it did, right? And if it's on the outside, it went down 6, which it also did. So a linear function, there's really no distinguishing between inside and outside, but it still is going to transform or slide the same as other functions. It's just that they're both the same thing, okay? All right, so let's look at one last example here. So we have the square root of x plus 3. So we have a plus 3 on the inside, but then we also have a minus 2 on the outside. So this one's going to have more than one thing happening. It's going to go left 3, and it's also going to go down 2. Okay, so we have a horizontal shift as well as a vertical shift. Remember, inside lies and goes the opposite way that you think it would, and outside does what you think it would do. Before I graph this, we need to think about what the parent function looks like. So the parent function is f of x equals the square root of x. So the square root of x sits at 0, 0. and then heads off this way. It's like a little half rainbow thing, right? So that's what the function looks like, the parent function. So this is what we're moving, left 3 and down 2. So right there is where it would start now, and then it's just going to head off this way. And I probably drew that way too big, because nothing else should have changed, right? Because everything else stayed the same. There was no like shrinking or growing or anything. So everything should have been exactly the same. It just moved over. Okay. So that's basically it for today. I'm going to redraw this. So it looks like this, and then it went over left 3 and down 2, and it looks about the same, so it would be something like that. Okay. So go ahead and give your assignment a try. Your assignment is maybe a little bit difficult to follow, but here's what it looks like. So it has, at the top, it has some functions. So like number 1 is f of x equals absolute value of x plus 7. So that's what number 1 looks like. And then it has the other functions up here as well, 1, 2, 3, 4. And then it has some graphs that are labeled with letters, A, B, C, D, E, F, G, whatever. So what you want to do is there's a line right next to number 1. What you want to do is look at this graph, this function right here, absolute value of x plus 7, and then you want to look over the graphs and you want to decide which one matches absolute value of x plus 7. So x plus 7 on the inside means that it should have gone left 7. Remember, this is a V shape that sits at the origin for the parent function. So look for the V shape that moved left 7, and that is what you're going to put right here. You'll put the letter either A, B, C, D, E, or F right here, depending on which one matches it. And then underneath the graphs, so for example, graph A looks like this, and it says underneath the graph parent function, and it says transformations. So where it says parent function, you're going to put right here the actual parent function, which is f of x equals x squared. And then the transformations, you're going to say, how did this function move from the origin? So this one went down 4. Okay, so these lines, parent function and transformations that are right under the graph, those are for the graph that it's right above. And then these lines out next to the function are where you will put which one of the functions, which one of the graphs matches this function. Okay. On the back, you're doing the same thing, but with 6 more functions. On the back, you need to make sure that you are noticing there are more than one thing. There's more than one transformation, sort of like this example here. Like it will have an inside and an outside change. Okay. So have a great day, guys, and we will see you next time.